So in this video, we will learn about frame of reference. To measure motion of any body, we need a reference point. For example, let's take a passenger in train. Now, this passenger inside the train is in motion or rest depends upon the reference point. If we take reference point to be a fellow passenger, then respect of the fellow passenger, this passenger is at rest. But this passenger in respect of some people on the platform is in motion. So to measure the motion of a body, we need a reference point. So frame of reference is a set of coordinate axes with an observer at its origin attached with the clock, with the help of which he measures the position, velocity and acceleration of a point body in motion. So what is frame of reference? Frame of reference एक कोऑर्डिनेट एक्सेस हम ले लेंगे एक्स वाई जेड और जिसके ओरिजिन से हम लोग मेजर करते हैं किसी भी ऑब्जेक्ट की पोजीशन, और पोजीशन मेजर करने के लिए हम उसकी जो डिस्टेंस होगी पॉइंट की एक्स वाई और जेड पे उसको नोट कर लेंगे एक्स वाई जेड, और विद टाइम यानी 4 चीज़ हम लोग नोट करेंगे एक्स वाई जेड एंड टी टाइम के साथ। तो इससे हमको जो पॉइंट बॉडी है उसकी पोजीशन विद टाइम मिल जाएगी, जिसके हेल्प से हम लोग डिस्प्लेसमेंट, वेलोसिटी, एक्सेलरेशन और सब चीज़ें निकाल सकते हैं। सो व्हाट इज फ्रेम ऑफ रेफरेंस? फ्रेम ऑफ रेफरेंस is a system of coordinate axes with an observer at its origin. Attached with the clock, with the Now, frame of reference are of two types. First is inertial frame of reference. So what is inertial frame of reference? Inertial frame of reference is a frame of reference in which the observer at origin is either at rest or moving at constant velocity. Inertial frame of reference is a frame of reference in which it's moving with constant velocity or at rest. Also in inertial frame of reference, Newton's law of motion, Newton's laws of motion hold good. And second type of frame of reference is called non-inertial frame of reference. So what is non-inertial frame of reference? It is a frame of reference which is moving with variable velocity or acceleration. That is a frame of reference in which its origin is moving with variable velocity. Or acceleration. It's called non-inertial frame of reference. And in non-inertial frame of reference, Newton's laws of motion do not hold good. Newton's laws of motion now you must be thinking that why Newton's laws of motion do not hold good in non-inertial frame of reference. So let me explain that. Suppose there is a body which is at rest. This is body A which is at rest. Acceleration is equal to 0 and force on this body is equal to mass into acceleration, which is 0. So net external force on a body which is at rest is 0. Now let's study this body A from a non-inertial frame of reference. So a non-inertial frame of reference is a frame of reference in which its origin is moving with some acceleration or non-uniform velocity. So suppose a frame of reference which is moving with acceleration a1, and this is body A which was at rest. On observing this body A from the origin of this non-inertial frame of reference, it would seem like that this body A is moving with an acceleration of minus a1 in this side with respect to origin. ऐसा इसलिए क्योंकि ये जो origin है वो पहले से a1 acceleration के साथ मूव कर रहा है. तो इस origin के रिस्पेक्ट में although ये बॉडी रेस्ट पे है, फिर भी इस origin से देखने पे ऐसा लगेगा कि ये बॉडी माइनस a1 acceleration के साथ मूव कर रही है इधर. फॉर एग्जाम्पल आपने कभी नोटिस किया होगा कि ट्रेन की विंडो से जब हम कोई ट्री देखते हैं, दो ट्री रेस्ट पे रहता है, फिर भी ऐसा हमको लगता है ट्री ट्रेन के अपोजिट डायरेक्शन में मूव कर रहा है. Literally from watching this frame of reference, this body would seem like to have an acceleration of minus a1. So due to this, so from non-inertial frame of reference, acceleration of body A would seem to be minus a1. So force on this body would seem to be minus. Already know that body A was at rest, so net external force was 0. But on observing from a non-inertial frame of reference, it seems like that some force is being applied on the body. That's why Newton's laws of motion do not hold good in non-inertial frame of reference.